So in today we will be starting with our third session of ML Bootcamp, and we will be seeing today KNN. It comes under supervised learning. So KNN can be both used for classification and regression purpose, but it is mostly used for generally classification purpose. Okay. So what is KNN? You must have heard the proverb that tell me about your friends and I will tell you who you are. Means if you are living with five genius mind people, you will be the sixth. Definitely, I can judge you. If you are living with the five uh, full people, I can tell you you are the sixth full or kind of. If you are living with 5 millionaires, you will be the sixth. That's the saying goes around. Okay. So similar manner, KNN works. Okay. So KNN is also called as instance-based learning. Okay, so I will come to this point later on. What is instance-based learning? But just to give you overview, what is instance-based learning? Instance-based learning means in the case of linear and logistic regression, we were continuously feeding our data to a machine. Okay, we were feeding our data, and on the basis of that, it was predicting. But in the case of logistic KNN, what it does is it stores the complete data. Whichever data I am passing to the system, it is storing the complete data. And on the basis of that, it is predicting the new point. But in the case of logistic and linear regression, it was trying to get new and new data at frequent intervals of time. Okay. So it is getting updated at each and every point. But in the case of KNN, your data is fast and it gets stored at once. Okay. So that's called instance-based learning. Means your the data is fixed, the model has already learned, and on the basis of that, it will do prediction. Okay. So this man has the laptop and he's trying to figure out which class it belongs to. And from the classes, he say that it is very similar to desktop. So it might be desktop. Okay. So that was one example. So you must have seen now we will see where Canon example is used. Okay. So if you are using Amazon, you must have seen this at the bottom of the page when you're purchasing any book. Suppose I'm purchasing any ML related book, you can see that customers who have bought this item also bought this. Means what they are telling to tell us that suppose I am purchasing any book, suppose there is a book called ML with TensorFlow. Okay, suppose I have purchased this book. At the bottom of the page, when you're adding the book to the cart or buy now, you can see this option customer who also bought ML with TensorFlow also has bought this book, Data Science from Scratch Python for Data Analysis. Means they are trying to maximize their sales. Okay, and you can see the things which they are recommending are related to my things. Suppose since I'm purchasing ML book with TensorFlow, they are related to this field. So they are not selling any toys or any eating product with the book. Okay, so it is trying to cluster the similar type of item. So it is generated for recommendation system. So you have also watched Netflix or Amazon Prime. In the case of Netflix, if you watch a comedy related series, Friends, you will be showing Big Bang Theory and other comedy series similar. So that's the general use case of KNN. It is used for classification purpose. Okay, so it is a powerful classification algorithm. Okay, so what is does, as I have told you in the instance-based learning, it is also called as instance-based learning. Instance-based learning. So it stores all the available classes, whichever data I'm feeding to the system, it will store all the data. So the data which I'm passing to the system. So this is my data D. It is storing all the data, and whenever I'm giving a new point to the data, it will predict. Okay, so data is already stored. It won't be getting refreshed each and every time. The data is stored as it is. Okay, on the basis of that, it tries to classify the new point. Okay, so it is also called as non-parametric lazy learning algorithm. Okay, so why it is called as lazy learning algorithm? Because it doesn't get updated at each and every iteration. The data which I'm passing gets stored. Okay. After that, it is not getting updated. And non-parametric means there are a very less parameters in the case of KNN. Means when you fine tune your model, when you try to improve your accuracy of the model. So there is only one parameter, that is your K. And what is K? K is your nearest neighbor. So I will give you an example of how KNN works. So you will have a more clear idea. Okay. So you have 2 points here. Okay, so you have red clusters and green clusters. And this is my point black. So it is confused whether I should belong to a red cluster or green cluster. Okay, so he will randomly select k is equals to 5. Means he will compute the distance and the whichever the points which are nearest 5 points, it will try to group them. Okay, so it has grouped the 5 points. and you can see the majority of points are from the green background. Okay, and so he will tell, so there are only 2 red points and 3 green points. So he will try to get into green points, means it is trying to मतलब ऐसा बोल सकता कि जो मैक्सिमम नंबर ऑफ पॉइंट्स है उसकी तरफ में वो अट्रैक्ट होगा. So this is our red. Again, this is our black point. You have 2 classes. One is called as green and which is called as red. He will calculate each the distance from each of these point. Okay. Now we will see shortly how the distance is calculated, and we will select the 5 points which are closest to the black point. Okay. So he has selected the 5 points, and he will see which are the closest 5 points. Okay. So in the blue circle, he has selected 5 points, and in the 5 points, he will select which are the maximum number of points. So he is saying he have 3 green points and 2 red points. So he must belong to the green points. So that's how KNN works. Okay. So any doubt in this example, or should I explain it once again? You just want it once again, how it is working.
Samiksha got it. Dhanraj too.
Just watch it once again. Okay. Okay, so you have got it. I must guess. So this the points belongs to now green class. So okay, that's how KNN algorithm works. So what in the previous example we have seen that there were majority of green points. So there were 3 green points and 2 red points. So the new point belongs to the green one because the majority of points were green. So that's how KNN works. First, it selected k values. K means first it was trying to calculate the distance from each of these points. It will select the least distance from the 5 points. And in the 5 points, it will see what are the majority of points belongs to. So in the previous example, we have 3 green points and 2 red points. So it belongs to the green class. So that's how our algorithm works. And the object is classified by the majority number of votes in the neighbor class. The object is assigned to the most common. So in the previous example, we have the 3 green labels and 2 red labels. Most labels were of green, so the points get classified as green point. Okay. So how the algorithm works, KNN. First of all, as we know that we will be loading our data set. Now we will initialize the k values. Okay, so this is the most toughest part in the KNN algorithm. So what a value should we choose? Okay, so the simple solution is you have to run your algorithm multiple times by choosing randomly k values. Okay, once you are selecting 3, 5, 7, and you will see which at what point of time I get the maximum accuracy, and you have to select that value of k. Okay, so we will be seeing how to choose the value of k. So for each example in the data, we will calculate the distance between the points. Suppose I have this data. Consider this as my data. And now what I'm doing is, so I have a new point this. Okay. So my algorithm decides that I should take 4 points in consideration, or 2 points in consideration. Okay, so it tries to calculate the distance from all these points. So it will try to calculate the distance from this, all the green points, all the red points. And what I will do is, since I have selected the value of k is equals to 3, I will select value of k is equals to 3. It will see which are the nearest 3 points. So we can see from this diagram. So this is my first nearest point, this is my second nearest point, and this is my third nearest point. And what I will do is I will plot a circle, okay, over these 3 points. So, okay, so this is my region. So once the region is selected, from this I can see majority of examples are of red class, and one is for we have 2 red classes and 1 green class. Okay, so the new points. So where does the new points belong? So the new points belong to the red class. Okay, so that's how KNN algorithm works. So what we does is we initialize our k value as 3. We calculate the distance Now we sorted the distance according to the arranging ascending order. We find the least amount of distance. So we find that these are the least 3 points in the K. So we pick the K entries. So in this case, we pick the entries of 2 red and 1 green in the sorted labels. Now we get the labels of the selected K items. So we have 2 red labels and 1 green label. If it is, so I already told you, KNN is used for both regression as well as classification. Okay. So, but mostly it is used for classification purpose. But if you are using in the case of regression, you return the mean. Means your average value. And if you are doing the classification, you will return the maximum value out of it. Okay. How to calculate the distance? So since we have seen we have to calculate each and every distance of the point in my data. Okay, so this is my graph. And I am getting a new point here. Okay, so I have to calculate the distance of from this point to this each and every point. Okay, I'll be calculating the distance, and for calculating the distance, we have mainly use two formulas. One is called as a Euclidean distance. Okay, what does a Euclidean distance is? It is simply the square root of x2 minus x1 square plus y2 minus y1 square. Okay, so either you can use the Euclidean distance or you can use the Manhattan distance. And what is Manhattan distance? It's just the difference of the absolute values. So in Euclidean distance, I'm doing 5 minus 1 square plus 4 minus 1 square whole root, and I'm getting the value as 5. But in the case of Manhattan distance, I'm doing 5 minus 1 modulus plus 4 minus 1 modulus, and it is returning me the value of 7. Mostly we use Euclidean distance in the case of k nearest neighbor. Okay, so this was a formula for your k nearest neighbor Euclidean distance under root of x2 x I square minus y I square, where your x is x1 x2 x till xn and y is from y1 to till yn. Okay, so we use Euclidean distance for calculating. So since I told you that the most difficult part is the choosing the right value of k. Okay, so if your value of k is too small, it will have higher dependencies on the result. So what does this mean? So we'll take a practical example of this. Suppose you have just graduated from your college and you went to a job fair. Okay, so you went to a job fair and suppose you choose the value of k is equals to 1. Okay, just consider the value of k is equals to 1. You hold a engineering degree in computer science. Okay, so you went to the first counter and your value of k is equals to 1, means you are only visiting one counter. And from the first counter, they say they are only hiring people who knows UI UX. So you will be getting disappointed since I am a CS engineer, but they want to hire a UI UX developer. So this might not be the career fair for me. मतलब तुमने बस एक को पूछा and on the basis of that you are concluding that कि नहीं ये तो बस UI UX वालों को ही ले रहे, इंजीनियर को नहीं ले रहे. So in that case you are overfitting the model, means you are over generalizing. Since in the career fair there are tons of stalls, so there are many number of stalls. But since you are asking only one stall and the one stall has to be the UI UX, so they want UI UX designer, but you are CS degree. So they will be telling that we want only UI UX designer, and you will be getting disappointed that I came to the career fair thinking that I will be getting a job related to CS, but you only counted the first counter from the whole. If you were able to ask the second or third or fourth, you will be getting to know that they want an Android developer or Flutter developer. But since you ask only the one of the department, you get disappointed and you go home. So in the case of k is equals to 1 means when your k value is very less, your model can be overfitted. Okay. And if you take too large value of k, in that case, your principle behind KNN gets destroyed. So you have to take a medium value of k. Okay. So there is a rule that when you are odd even number of classes, means you have 4 classes to classify. Suppose there are class A, B, C, and D. In that case, you will take k is equals to odd number. Suppose this means you will take 1, 3, or 2, 5 values, because if you are taking an even number of classifier, then what will happen? So there might be a possibility that you will group all this data. and two data can be from AB class and another from the CD class. So you will be getting confused now which class I belong to. Therefore, when your classes are even, you take odd number of k, and when your classes are odd, you take even number of k values. Okay. And as a thumb rule, what we should be a value of k is your number of examples. Suppose in your data set you have 1000 points. So what should be your k value? So you will be doing square root of 1000. Okay, so that should be your k value. Okay, so either you can use this formula. So you have to keep all this formula while choosing the value of k. So the biggest is you don't have to take the value of k too small or too big. It should be in the range of k should be less than the square root of n, where n you belongs to the number of examples. Okay, so that's how you choose the value of k. So this is my example. So what happens when I choose my value of k is equals to 3? So I have this data point, yellow data point, and if I'm choosing the value of k is equals to 3, it tries to calculate the distance from this, and this point, and all other points. But he sees that since my value of k is equals to 3, I will select my nearest neighbors. So what are the nearest neighbor? So this is my nearest neighbor 1, 2, and 3. And from these three, I can decide the majority belongs to the green class. So this point will be green in that case. Suppose I'm taking the value of k is equals to 7. So in that case, what will happen is, so this is, it will calculate the distance from all these points. So the nearest points will be, so this is my first nearest point 1. This is 2, 3, 4, 5th, sixth, and this will be your seventh one. So we'll draw a boundary around these points. So from these 7 points, I can see my majority means there are 4 red points and 3 green points. So I have 4 red points and 3 green points. So which class I will belong to? So it will belong to the red class. Okay. It will belong to the red class. So that's how KNN works. Okay. So you have to take the optimum value of k. So this is the only hyperparameter in the case of KNN. So just the example I have given of you of the job fair. So you have this black point, and what does the black point does is it says, so I will select the value of k is equals to 1. Suppose there may be an outlier. Outlier means a false example in a correct examples. So means like there can be a case when you are going to job fair, there will be a, suppose there are 100 stalls, but there can be only one stall that are hiring UI UX designer, but you have CS degree, so you want to get hired by the only Android developer. So मतलब तुम्हारी किस्मत, your fate is so bad that you go on the system which are hiring UI UX designer, and they are saying that no, we are hiring only UI UX people, and you get disappointed and you went home. So there is a case in the KNN, means there can be an outlier. So this is the false blue point presenting the red points. And if I'm taking the value of k is equals to 1, so what the algorithm will say is, so I will belong, nearest neighbor is my blue point, and on the basis of that, it will draw the conclusion that I belong to the blue class. But you can see most of these points belong to the red class. So you have to take the optimum value of k. Optimum means not too large, not too small. Okay. So this happens when you take the value of k is equals to very small. But as you take the value of k is, so in the first case, we chose the value of k is equals to 1 in this case. So that's why this issue happened. But when we choose the value of k is equals to 3, so it will take a 3 nearest points. So this is a 1 point, second and third. So what can it can conclude that I have 2 red points and 1 blue point. So I must belong to the red one because there are majority of red. Similarly, in the case of when you went to a job fair, you went to the first hall. The first hall say we are hiring UI UX one. The second one says we are hiring Android developers, and the third one also says we are hiring Android developers. So you came to a conclusion. No, in the fair there are people who are also hiring Android developers. So I must explore more. But if you choose a value of only k is equals to 1, so you will be getting stuck and you will be oversimplifying your model that the job fair is only about UI UX people, so there is no need of mine. Okay. So in the when you are performing k-nearest neighbors, so there is one thing called as feature normalization.
Previously, I just want to tell one thing. Can you go back to the previous slide?
This one?
Yeah. So everyone, just pay attention. In those like red dots, there is only one blue square. You know, like what such data is called? It's also referred as noise. Okay. Okay, nice ringtone. So this is called as a noise, and like just remember what can noise be stated as. So it's nothing, but you can say that an instance whose features value does not match is label. Okay, so features, like we always have an exception, right? So a exception in data, that would be a noise. Okay. So yeah, moving forward.
Okay. So there in the real world scenario, in the real world data set, you have a lot of noise. So you have to do the pre-processing kind of things in machine learning. So similarly, when we are using KNN algorithm, it is we have to do feature scaling. Means there are values ranging from zero. Some values may be ranging from 0 to 10. Some may be ranging from 1 to 40,000. So it is very difficult for the model to predict. So what do we do? We do the feature scaling. What feature scaling means? You are taking the values between 0 to 1. Let it be any value. Let it be from 1 to 40,000, ranging from 1 to 40,000, or it can be ranging from 0 to 10. What feature scaling will do it? It will convert your values in the range of 0 to 1. So it does this. It will take your current value minus the minimum value in the column divided by the maximum value in the column minus the minimum value in the column. So you don't have to implement this formula. There are each and every library available in the scikit-learn package. So you don't need to worry about the formula, but just make sure before performing KNN algorithm, you have to do feature normalization. In huge data set, if your data set is too small and you don't have features ranging from very different scale, in that case you can avoid this step. Okay,
Remember, we
so
did this thing in logistic regression, right? We did a pre-processing, we did a normalization.
yes, so you have to do this step in each and every algorithm if your data set is ranging in variety of ranges. Means you are ranging from 1 to 40K, other are ranging from 10 to 25 only. So in that case, you have to do some pre-processing, and in pre-processing step, you have feature normalization, which maps the value between 0 to 1. It can be any value. Suppose your salary is 25K. Okay, your current salary is 25K in the column, and you have to do the feature scaling. So what it will do is it will take the current value 25K minus the minimum value. Suppose in the your minimum value in the data set is 10K, it will do 25K minus 10K, and the maximum value in the data set was 50K. So what it will do is 25K minus 10K divided by 50K, and the minimum value was 10K. So it will do the feature scaling, and it will give me the value between 0 to 1. Okay. So you have to do some pre-processing. Your data set ranges from very large values. Okay.
Again,
So
why do you need it? Because if, like, just imagine you want to go to a place. Okay. One friend is walking there, one friend took an auto, one friend is going through his private jet, and one friend is going through cycle. What would happen? There would be noise. Someone would reach like before, someone would reach months later, someone would reach years later. You don't want that. Okay, so you'll just grab each one of them and fix one mode of transportation. Okay, you want to fix one mode of transportation, or you can just say that, okay, what you do, you can use bicycle or you can walk, because they would be ranging almost similar. Okay, so you fix a range, right? You fix a range. So here from 0 to 1, so mathematically, why 0 to 1 or anything, it's easier to compute, right? If there are huge numbers, then you need huge computational power. Why worry? Just divide it, use normalization and everything. Whatever would be valuing, it would be valuing from 0 to 1. Easier compute. That's it. So yeah, Aditya.
okay, great. So that's it. Okay. So you have any doubt about this? Any doubt about any topic which you don't understand? How KNN works?
Just type it in chat box, or we'll move ahead with our, what do we have today? digit recognition, right?
Yes.
Yeah, digit recognition with KNN. So doubts, no doubts, anything you want to write in chat box, just write. Exhausted, no doubts, okay. Shilpa has no doubts, not does Harshila. The girls are very attentive, right? We boys
What
sleep.
about boys? Okay. So you just
What
switch
is
on
the
the
next?
Nexus and go to
So
sleeping or anything.
arrange, and after sorting, if we get the same number of both colors. Okay, so Vaibhav, that's what we have been doing,
Yes.
right? See, if किधर हो class वाला?
Yes, yes, yes.
Right. So if you have two classes, okay. So what I'll do, I'll select k is equal to 3. Okay, anyone has the same doubt as Vaibhav? If there is a binary classification, I'll select binary classification. If anyone, okay, let's suppose if Vaibhav has corona or not. So Vaibhav has corona or Vaibhav doesn't have corona. Okay, just for understanding, don't take it personal, Vaibhav. Okay. So what I'll do is I'll fix 3k nearest, like 3 neighbors or 5 neighbors. Okay, so what I'll select odd number of samples. And why is that? Because it is a binary classification. That is, you can either have corona or you can either don't have corona, right? So if I'll select odd number of sample like neighbors, so okay, so if you have 3 neighbors, so what I'll ask is I'll ask one neighbor, I'll ask another. Okay, so like this conflict could not happen because at least two will have same class, and like there would be an odd man out, right? There will be always an odd man out for binary classification or even classification, right? So if Vaibhav's 3 neighbors, if two of them has corona, one doesn't, so we will consider that Vaibhav has corona. Similarly, if we are selecting 5 neighbors of Vaibhav, then let's suppose 3 would be having corona, 2 won't be having, or 2 won't, or let's say 3 won't be having corona and 2 would be COVID positive. So we'll select Vaibhav is COVID positive or not accordingly. So Samjha, like it's like this.
Okay, so let me explain once again. Okay, so you have suppose you have four classes. Okay, or yes, you have four classes, and you have this data set. Okay, so for easier understanding, we will just take two classes. Hold on.
हाँ लग हो जाएगा. Okay,
Yes.
in fact, odd के लिए can we make an odd one?
Yeah, hold on, just hold on. Okay.
Mm,
So this is my point. Okay, so I want to classify this point. So we can say that from this given data, we have two classes. One is your red class and one is your blue class. Suppose, but you have to just make a thumb rule. So if you have even number of classes, in this case, we have two classes. If you have even number of classes, you will take odd number of k values. The k values can be 1, 3, 5, 7, and so on. But if you have odd number of classes, so if you have 3 classes to predict, or if you have 5 classes to predict, in that case, we will be using two k arrays near neighbor or 4 or 6, even number of k values. So in the since we have two classes, we will be selecting the odd values. Suppose I am selecting 3 values. So what will be the nearest 3 values? Uh, I guess so. These will be the nearest 3 values. So this is just my random prediction. So what I can see from this data is we have 2 blue points and 1 red point. And what
see,
I can
there would be
consider,
at least one odd man out. Okay.
yes, there will be at least one odd man out. Okay. So what is that? And the one that belongs to odd man out class category will have large number, since here are two category, 2 blue labels and 1 red label. So what happened is this new point will belong to the blue class. So that's what it is doing. That's what it's happening. Okay, so what we'll do is we will again take an example of an order classifier. Okay.
In fact, it could be like this, that the point is near to like it's saying that all 3 are from blue or all 5 are from blue. So that could also happen. So basically, you just have 100% surety that the particular point is like lying in the particular group. So it could be either way. But if you are having a binary classifier and you select 2 neighbors only, so then it could happen. कि yeah, if I belong, like there is 50% chance I belong to red, there is 50% chance I belong to blue. This could happen. So just to avoid this, for even we select odd number of k, for odd we select even number of k. So easy as that.
Okay, so we have here three classes: blue, red, and yellow. And since our classes are three, means it's odd number. So what will be your k value? It can be an even number. So we can select two values or four values. So for simplicity, what we'll be selecting is we will be selecting four values. Okay. And this is our next new point. So what we will do is we will classify 4 points according to the new ones. And we will be getting a circle like this. And what we can see from this circle that we have two blue points in the circle, one red point and one yellow point. So my new points belong to the blue class. Okay, Vaibhav, I hope you have the doubt clear. Means if your classes are odd numbers, your k will be even number. Just note down. When your classes are even numbers, you take it as odd number of k. Okay, Vaibhav has cleared out. Anyone who has a doubt about this?
Okay, Aditya, let's proceed further. Like you can ask your doubts. I'll be explaining, don't worry. So we'll just move towards coding because then we'll get late again.
Okay.
In the meantime, you can ask your doubts. Okay, no problem.
Atharva, I have shared you an image. Can you just show the image or should I show the image
Where did you share?
on WhatsApp?
यार
Okay,
बहुत
just don't open. Let it be. Let it be. Let it be. Don't open.
Yeah. Okay. Mail it to me. I'll open my mail.
Okay, sure.
WhatsApp is personal, man. Or you can, in fact, drop it in our chat. I think. Yeah, there is an image option. I think. Here, I think we can drop images as well, so you can do that. So yeah, quickly going towards our favorite collab.research.google.com. And just let's create a new notebook. Okay, so we would be dealing with images today. Malab not basically images, but we have a converted pattern. And I want you to know what we have converted it into. So what we
Okay.
using?
Hold on, Atharva. Just open your chat box.
क्या बात है?
Okay, so just now just zoom it a bit. Okay, so just now we taught the example of how an outlier is. So you can see the extreme right one is the cat, but the three are sitting as dog. So there can be a case that you have some random different data points, but it is there in your class. So it may not be present in the original class, but it may be kind of spying, or there can be a point. So that's happen when you have outlier, and when you choose k is equals to 1, it will happen that it will classify it as only cats, but the original it is the all three are dogs and there is only one cat. But if you take the value of k is equals to 1, what it will say is no, it's only cat. Okay, so for this purpose you have to check the normal or minimum value of reasonable value of k. Okay, so that's why I have shared them.
Call
Okay.
an emergency meeting. We have to kick him out.
Yes.
Uh,
Okay, just go on.
Yeah, so the dataset we would be using is called as MNIST digit recognition dataset. Okay, so it's called this dataset. Do we have some samples? No, wait. So this is
Just
the
check the images, just check the images one.
I think images में होंगे. Yeah, see. So this is a MNIST dataset. So it contains human written 0 to 9 like characters. And what we are going to do is with KNN, we are going to provide a image, a converted one, and the model will try to predict whether it belongs to 0, like whether the thing written is 0 or 1, 2, 3, 4, whatever it is. Okay, so that's what we are going to do. So this is how the data set looks like and it contains around, I think, 40,000 samples. Okay, so 40,000 samples of all these, and from that we are going to create a character recognition model using KNN. But before that, I want you to know some things, and what I'll do is, there was a site, why do math image basics. Okay, did you see the there was a nice recommendation. Okay, so before going into images, so you know that the machines can only understand one thing, and that is numbers, right? Machines only know numbers. So it can't know human language, it can't know anything else. Pardon my handwriting, I'm very bad at handwriting, and I'm left-handed, by the way, so it's a bit awkward for me. So machines only know how to deal with numbers. So what about language or any images or whatever else? So fun thing is, image is made of, what do you call it, pixels, right? So pixel, yeah, and this stands for picture, this stands for element. So a smallest element in a picture is called as pixel. Just like everything is made up of atoms, so pictures are made of small pixels, right? Everyone must be knowing this thing, I guess. So moving further, what happens is, just imagine we have this image. Okay, let's say it contains 9 pixels. So okay, 1 2 3 4 5 6 7 8, I'm sorry, 8 and 9. So these 9 pixels we have, and each pixel can take a value of 0 to 255. Okay, so what did you get right now? There is an image. Let's say there is a beautiful, uh, like, I don't know, there is an image of a man. Okay, and he is on a vacation. This could be mountains, I don't know, here must be some clouds and whatever. So this image, and it contains 9 pixels. Okay, so each pixel can get a value from 0 to 255. And what is this 0 to 255? It's actually called as like the brightness, or you can see the like whiteness of particular image. Okay, so 0 means black and 255 means white, and in between there would be all the gray shades, and you want to see the gray shades. So where is the, yeah, see, so this is how the gray shades are. These are the total 255 gray shades that are available. You can even visit this site, it will tell you properly what pixels are, and I'll try to tell you by myself as well. So this is what a pixel is. Okay, so see this image, for this image they took a bit portion of only this side, a very small portion from, I think, bottom left or something, and this is a pixel. Like these are all the possible numbers from 0 to 225 the pixel can have. So these could be probably closer to 0, and this could be probably closer to 255 and all. Okay, and now why 255? I'll just close these tabs. Why 255? Okay, so 0 to 255. Everyone knows basic of computing, a thing called as bit. Okay, we store our data in bit. The site didn't refresh. Yeah, yeah, see. So everyone knows a bit. Okay, a bit can take two values, 0 or 1. Right, 1 byte consists of 8 bits. Right, everyone knows this thing, it's completely basics. So 1 byte contains 8 bits, and what happens is that 1 pixel stores its value, that is from 0 to 255, in 1 byte. So 1 pixel uses 1 byte to store its values. Okay, so 0 to 255 means 256 numbers total, right? Because we are computing from 0. And if you just make like try to have some logic, there is a 8 bit, okay, 8 bits. So 8 spaces, 3, 4, 5, 6, 7, 8. I'll erase the unnecessary part. Okay, so 8. So it could be 0, 1, this could be 0 or 1, this could be 0 or 1, this could be 0 or 1. So totally, if you convert this binary into a number, it could be total 2 to the power 8. That is 256 number of, like 256 combinations, you can say, if you apply permutation combination. Okay, to the power 8, 256, right? So 256 different values that could be taken by a pixel, and 1 pixel stores in 1 byte. So this is the basic you need to understand. So now our data. So how our data looks like before that. Okay, so I have uploaded the data. Let me show you. Week 3 MNIST digit. Just click on view raw and you have this data with you. Copy and have it in your chat box. So everyone just use this data, like copy this link we would be using right now. Start your collab notebooks right now, and we would be performing our MNIST digit recognition now. So as usual, let's import numpy as np, and let's import pandas spd. And by the way, any doubt in image? Yeah, what images and anything else? Just quickly, yes, no, whatever. Got everyone? It's just two easy concepts that 1 pixel uses 1 byte of memory, and 1 byte can have 256 number of combinations. So 256 number from 0 to 256, 1 pixel can take any value. And what is that any value? So 0 would be black, 255 would be white, and in between there would be gray, like the shades of gray. Okay, 255 shades of gray. Don't get it wrong, it's not 50. So anyone who told that 50 thing, they are wrong. It's 255 shades of gray. Okay. Yeah. Only some legends would get this one. So now we imported our data set. Okay, many people got it.
Clever people.
No, they're mature enough. Okay, so we'll read CSV. Did I copy the link? ओहो ओके, वैसे भाई मैम के पास लिंक थी, मैम आई है क्या पता नहीं. नो प्रॉब्लम. ठीक है, पढ़े थे यार.
We were
And
talking
for
about studies, okay? So yes, images about, not other than that.
yeah, images पे ध्यान दो भाई. Whatever rubbish I talk in English, don't worry, it's just rubbish. Okay. Yeah, so let's see our data. So I'll encourage trying it with me. If you're not, no worries. So this is how our data looks like. कुछ भी नहीं समझ रहा, right? You don't get a thing. What is this 0, 0 and everything? What is it written? So I'll clarify it to you. So first column, see this. It says 5, 7, 9, 5, 2, 0, 1, 2, whatever it is. So this first, like what is this called? Okay. Other thing is some data, and I told you in MNIST we are going to classify from 0 to 9. So what this first column would be called? There is something called as X and Y, and in Y we used to fit something LA. What is it? Go little slow. Okay, Samiksha, I'll go slow. Anyone answer what this 5, 7, 9 वगैरह could be? Okay, this thing ranges from 0 to 9 again. Okay, so there is a thing, label, if anyone remembers. So this is our label. The first column is our label, and other is our data. And it is low. Sabiksha, do you have any like doubt or something, or any part you want me to repeat, or we'll go further? Okay, great. ठीक है. So I hope that anyone who's trying with me has now imported libraries and used the imported the data, showing this data. So now, okay. So how many number of rows we have? We have 20,000. So in original MNIST, there are 40,000, but to easier the computation, I used only 20,000. Okay. I selected 20,000 random samples and I created a shorter version of the original MNIST. Notebook link, Alisha, I haven't uploaded the notebook. Sorry for that, but I upload it as soon as I am done with explaining because I don't have it now. I'll write, then I'll share. Na, how can I directly share? But viewable link दे दो क्या? Notebook will be shared at the end
Okay,
of the session.
you could just try to code with Atharva.
Try with
He will go slow. By the
just
end of the lectures, we will be uploading the notebook on GitHub.
yeah. So you can refer it later, but right now it would be good if you would be trying it with me. So just did two things: imported our notebooks, imported our libraries as always. Sorry, and we did read CSV, and I gave the link for the CSV in your chat box, and I have the data right here. Okay. So first things first. So in MNIST, what do we have is we have uh, let me clear this thing. Now we are talking about MNIST. So in MNIST data set, we have 28 pixel by 28 pixel. Okay, that type of image. Here it's very slow. Whiteboard. लिख भाई जल्दी. Actually, I wrote it some time ago and it's processing very slow. Okay, MNIST 28 by 28. So what is 20 for an image there would be 28 pixels by 28 pixels. Okay, so total how many pixels? 28 into 28, 784. Okay, 784 total pixels for a particular image. Got the point? Seven 84 pixels for one single image because 28 into 28, 784. Okay. So now let's see our data one more time. What do we have? 785 columns. Out of that, first column is label. So what could other columns be? Other column would be pixel values, right? And what does this pixel value range from? So these pixel values range from 0 to 255. Okay. So what did we do is 255. Yeah, okay. So what did we do here is in a single row, like see 28 by 28 image we took that image and we reshaped it into a single row. Okay. So 28 times 28. Okay, 28 times 28 would be 784, right? 784. So we have 784 pixels, and what I did was I flattened that image out for easier computation. Okay, I flattened that out. So 784 pixel values I have, the values that range from 0 to 255, and what I have these 20,000 images of that, and 784 are column numbers, 784 are pixel. So the one other column would be nothing but the label. Okay, so the first column is our labels. So the first image would be 5, second image would be 7. You are getting these things? Now let's try it in code again. Okay. So what we'll do is, why believe me? Huh? Who am I, God? So don't believe me. Just ask the code what your data ranges from. So describe is the best way. Okay. So he's like here you can see there are 20,000 samples, almost 20,000, right? And here you can see maximum value. Okay, so maximum value is 9 because this first column is labels and labels range from 0 to 9. Okay, so it could be 0, 1, 2, 3, 4, 5, 6. Okay, from 0 minimum to 9 maximum. Always the minimum for each and every pixel would be 0, right? And maximum. So these could be the end pixels. So that's why they have maximum 0. But in some point of time, see, 216. Okay, so some pixels are going till 216, some would be 255. Okay, see we have 255 here. So these could be probably the pixels that are in middle, because middle would be many times the middle session would be activated fully. Okay, so it will have a complete white. So for complete white 255, right? So see 255, 255 and all the others. Okay, so from 0 to 255 this is the ranging. So I told you correct, but you didn't want to believe me in the first place, not my night. Okay, so now what I'll do is I'll just convert this data into a numpy array, so for easier computation. And what my x is, okay, so now I'll slice the data, and by slicing I mean is that from I think one, yeah, see, so now what I'm doing is in Python or any programming language, like many programming languages excluding R, we compute, like we start counting from 0. Okay, so 0th column, first column. So for X, what I want is, so this first slicing, this means that from dash to dash, like this empty and a colon between, this means that I want to select each and every row. Okay, so for X in data, I want each and every row. And from columns, okay, so row comes first and then columns comes after that. So I want each and every row, and for columns I want everything excluding the first column, that is my label. So I didn't include 0, I include 1. So from 1 I want everything. So I have my pixel values like here. Okay, and for Y similarly, what do I need? I want data. Okay, and in this I want each and every row, so I leave blank. So I want each and every row, but I only want the first column. So first column is 0. So I got my X and Y. And if you want to see, so now these would be converted into numpy arrays. Okay, so numpy arrays we previously discussed, they are faster to compute and everything. Okay, so let's see the let's see the shape of X and y dot shape. Let's print it out. So see 784, what are 784? 784 are the total pixels, and these are the number of rows. Okay, we have X and Y shape. Let's try plotting one. Prachi, what can't you understand? Can you just tell me which part? And what I'll do is I'll try to show you how these images are. Give me a number. Give me a random number, everyone. 1, 2, 3, 4, anything. Come on, fast. Chat box. Random number. 9. Okay. Alicia, thank you. 9. Okay. So 9 sample, and I'll do it what I'll do is I'll reshape it into 28 by 28. And CMAP would be, I want the image is grayscale, so that's why I want to see a grayscale image. I think matplotlib import nahi kiya. So I'll import matplotlib.py.plots plt. Looks like 2. Looks like 2. Let's ask Python itself. So 9th sample we selected. Tell me its value. 2. See. So what I did here was I just converted. So see, I told you na, in one row I flatted out each and every pixel, and those are 28 by 28 images. So what I did was I selected one row and I reshaped it into pixel of 28 by 28. So it will show me the original value. So now it like the original image. So it's showing me the original image. So this is the original.
Can you just go from the top once again? Prachi has just out. Yes.
Okay. Wow. Okay. Now find it interesting. Just a second. We can try any other number. Let's see. We printed here now. So let's see this first row. First row would be sample 0. So sample 0 I selected. I reshaped it into 28 by 28 because that the image is 28 by 28. So the sample 0 is, it looks like 5. Let's see what the label is. Label also says 5 right here. Yeah. Let's print it out from this labels. See 5. Easy peasy. Okay, and from the top, who wanted Prachi? Okay. Which part, Prachi? So I imported my libraries here. Then I just did like our favorite, we did a trade CSV, and I gave the CSV link to you. In case you missed out the link, just go to our repository, and here in the week 3 I've uploaded MNIST Just view raw, copy the thing. Okay. Then I just printed the data. I use data.describe. Okay, do one thing. I'll just give you the viewable link here. Anyone on the internet can view. Okay. Here you have. You can open this link. You can check it out yourself. No misusing, although you can't, but still. So any other number? Anyone wants to see any other number? Okay, you saw how the images are. So I did nothing. So like if this is an original image, I just reshaped it into what? A single row, and I like packaged it into my MNIST dataset. So that's how MNIST dataset is working. So now I saw the label for the, I use 7th only, no? Achha, I think 0. Achha, I did 0. So see, for the 0th, we have the label 5. Right. So now our favorite print split. So from sklearn.model selection, okay, learn import train test split. We have our train test split. Now, as always, x train, x test, y train, and y test equals to train test split, and we'll use our x and y. And test size, how many samples do we want to separate out? So let's say 0.2. Okay. So we have our x train, y train, x test, y test. So now we'll use our model. So we need to import our model, and we'll just fit our model. So model equals to k near क्या नाम है उसका, k neighbors I guess. I think spelling classifier. Okay, did I import it? Import नहीं किया ना, sorry. अरे यार. From sklearn.neighbours import a nearest classifier. Okay. So k neighbors classifier. Now does it work? Spelling गलत है क्या? No. Okay. So now I used my I imported my model, and I want to fit into my model my data, my x train and y train. Okay. And by the way, in this what happens is nothing happens. And why I'll tell you nothing happens? Because when you fit, okay, so for in linear regression and everything, when you fit, you are trying to use the best fit line and everything. But in k nearest neighbors, what actually happens is, so suppose you have this data, okay, so you have 0 0 0 and x x x, right, and this square. Okay, so now what we have done is we had this kind of data. Now there is no square. We had this kind of data, and what we did was we just fit on this data. So we fit on this data means we did nothing, कुछ भी नहीं किया, because we just took the data. Now, when we have a new data point on which we are trying to predict, okay, so this square, now I'm trying to predict where does this square belong. So when I have a test data point, right? When I have a test data point, that time only I can compute the distance from this point, this point, this point. Like all the other points, I can compute the distances only when I have one data to test on. Okay. So in fit, basically we do nothing, just data लेके रख दिया. So we just took the data and we kept it to ourselves. We did nothing, no computation at all. When we have one test, like when we have a test, once we have a test sample to predict on, so that's when uh, the actual computation happens. So that's when I'll find the distance between these all the other points, and then I'll select the my number, like what, how many numbers am I selecting, how many neighbors am I selecting, and accordingly then I'll select, yeah, this probably belongs in the X, like X label. Okay, so like that. So the point was that whenever you're trying to fit a model, actually nothing is happening unless you have something to predict on. Only for k nearest neighbors, okay, not for any other else, because for linear regression or for logistic, you are trying to fit the baseline and you are trying to minimize the error and everything. So here you don't have such thing. What you're doing is you are just taking a new point and you're just trying to calculate the distance, and wherever has the distance minimum, okay, the lowest distance, so this point, wherever this point has lowest distance, you just say that, okay, probably this point belongs to that particular class. So that as easy as that. So in model.fit, basically we just kept the data to ourselves and we did nothing. So now let's try to predict, and I'll predict on just some samples. Let's say starting 10 samples. Okay. So starting 10 samples, let's predict. Okay. So I gave him the first 10 samples and these are my predictions. So now, like actually on this line, what happened was they used all the like this data. Okay, 784 rows in each. So 784 rows for first, 784 rows for second. For each and every one, they tried to calculate the distance, and accordingly, so they predicted, okay, so that probably the first point lies near 6, so probably it could be a 6. Let's see what were the actual samples. So X test and the first 10. So this is my prediction and this is my actual. So see, actually 6 was 6 to 6 is 6. So do we have any wrong? No, we predicted everything right. Only for first 10 samples, right? So yeah. Now let's see if we want to plot one more. I just copy it. So let's see how the data actually looked like for X test. So which one do you want to see? Let's see this 0. So where is this 0? 0, 1, 2, 3, 4 on 4th. See. So this was the image and the model said this is a 0, and actual labels also said that this is a 0. Okay, we don't have any incorrect predictions, so let's try from 10 to 15 and 10 to 15. For okay, so this 10th sample is incorrect. Yeah, see, so this 10th sample, okay, what my model, what my KNN classifier said, it said that I think it looks like 9. And why did it think that? Because it was closest to 9. But when test, like the actual label for this image was 4. Okay, 4. And I tried to plot this thing. So see, it is a 4, but the model confused it with 9. So it could happen. Okay. And let's see how accurate our model is. So I'll do just model dot score and X test and Y test. Let's select for, let's say 100 samples. Okay. So for first 100 samples, it calculated and it said that I was correct 91 times. So out of 100 samples, 91 samples were correct. So my accuracy of model just for this 100 samples, okay, I only took the first 100 samples, it's 91. So let's try complete data. I don't know how long it will take because there are lots and lots of distances, and it will try to predict on each and every distance, right? For each and every row, it will try to predict the distance and everything, and it will find the minima. So I think it will take a lot of time. So whatever time it takes. Now, one more interesting fact. Okay. You saw 785, 784 columns were, okay, let me get the whiteboard. So somehow what actually happened when I did model.predict. So what happened when I did model.predict? We had 784 pixel values. So basically in KNN what happens is we have our data again. Okay, so we have our data here, and each and every point it contains 784 values. So see, this is a 2D. This could be X, this could be Y. Okay, Y would be label. So this would be X value. Okay, let's say 3, and this could be the like this is a 0, let's say. So this would be 0, and 0 is what? 0 is my label. So basically every point here would be a 0, like near to this thing. Okay, so now what I did, it was only for one feature X, but how many I have 784 pixels. So basically this would be plotted in 784 plus 1, that is label. So 785 dimensions plot. So for 785 dimensions, KNN probably plotted a graph, right? That's what happened. And for 785, like for 785 dimensions, we have the plot, and then it calculated the distance between the points. Let's say this is a test. So from the distance between these points, each and every point, it calculated distance at that instant, and then we had the prediction. Okay, so calculated distance, shortest distance is between these points. So probably this number lies in 0. So this could be a 0. And how it did was 784 values. So x 784. Okay, and some other also there could be a point. And then for 784 values, the distance for 2 points is root x1 minus x2 ka square plus y1 minus y2 ka square. Remember this? We had this for 2D, like distance between 2 points. So now there is distance between 784 points. Crazy, right? Yeah. Okay. So, well, इतना ही था. KNN MNIST digit. Okay, one more thing, one more important concept. Yeah. 1 second. So now this is a class. Now for every classification problem, always remember what we have always for classification problems. We have one thing called as confusion matrix. We have a confusion matrix. Okay. Let's say here we have distance का formula हटा देते हैं. Here we have true labels. Here we have predicted labels. Okay, so this is for binary classification. Binary, right? So it could be 0, 1, 0, 1. This could be COVID positive. This could be COVID negative. Similarly, 0 could be COVID positive and COVID negative. So for 2. But now what we had 10 different classes. How 10 classes? Because it could be 0, 1, 2, 3, all the way till 9. So we have 10 classes. So for 2 classes, our confusion matrix is of 2 to the power 2, that is 4 squares. For 3, it could be 2 to the power 3, that is 8. So now our confusion matrix would be of 2 to the power 10, whatever that number is. Okay. So 2 to the power 10 number of squares we would be having here. So whatever it is, it will just go very dirty. So that is about confusion matrix. And one more thing. So just one last concept. So let's suppose for binary classification, and it is about COVID patients. So if we are dealing with medical data, let's say 0 and 1, 0 and 1, 0, negative, 1, positive. Just one last concept, then we'll wrap it up, because this is very important and many people ask this in interviews. Okay, I got asked this thing in one of the interviews. So COVID patient data, now this is, let's say, our prediction, and this is actual value. Okay, so this is called as true positive because the patient was negative and we predicted it negative. Okay, so the patient was not having, so this is true positive, this is true negative. You covered this in last one, I know, but we'll just revise this thing because one more thing I have: true positive, true negative. Now false positives and false negative. So falsely, so predicted positive. Okay, so falsely predicted positive, prediction was positive and it was false because actually the patient was negative. Actually the patient was negative. So that's why false positive. And similarly, like what do you, false negative. Okay, so your accuracy is given by true positive plus true negative upon the total squares. But when dealing with something like as COVID patient data or something like medical thing, okay, if anyone has any disease, what you try to do is you try to minimize the number of false negatives. Okay, because generally मतलब देखो, अब अगर किसी को कोविड है तो whatever goes, like you don't have any problem, but what you want to do is the people who are COVID positive, actually people who are COVID positive, you don't want to show in their result that they are negative, because this would be a problem, right? This would be a major problem if in a hospital the patient went to checking and he was COVID positive actually, but our model showed he is COVID negative and he'll roam in the world and spread more COVID. So that is not right. Okay. So what we try to do is we try to minimize false negatives, because bhad mein jaye. Okay. False positive, bhad mein jaye. Even if anyone is COVID negative in reality, if anyone is COVID negative in reality, but our model showed him COVID positive, so it was a false positive. But don't worry, what we'll do is this person will sit 15 days at his home quarantine. Okay, we don't care. It's like prevention is better than cure, something like that. Okay, so you don't care if this COVID like COVID negative patient in originally which we predicted COVID positive. So what he'll do is he'll just fit 15 days at home. Okay, we don't care about it. But what we try, like what do we want? We want to minimize false negatives. Okay, false negatives you want to minimize. So that's the point for medical data or something. So would be something else. So let's say if it's a SMS spam classifier. Okay, I'll ओके यहाँ लिख के देखता हूँ SMS, 1 second. हाँ, so just imagine SMS spam classifier. So now what do you want? False, like here you want false positive. So falsely selected as like falsely selected, that falsely just suppose for a student you had received promotion or something, like you have received an offer letter and it was predicted as a spam. So you want to reduce such kind of thing. So falsely predicted spam, that is false negatives, you want to minimize in such kind of data. So for each and every different kind of data, there could be a different kind of thing that you want to minimize. So for SMS spam classifier, it could be false negatives, because you don't want to you don't want to give out important information in spam. Okay, and similarly for let's say this COVID data, you want to minimize false positives, right? So just like that. So this is the concept we wanted to discuss, and let's go towards, I have a Kahoot. Just quickly we'll start the Kahoot. Okay, no challenge. No. Homeschool training host. Okay, so everyone, please join in. There is no lobby music. Sorry for that. I don't know. It has some issues with Safari. So join in quickly and let's wrap this session with this last Kahoot quiz. Okay. Anyone has any difficulties, you can freely ask right now and we can play Kahoot side by side. Anything wrong with today's session, just let us know. Link for what, Prachi? Ja, where is my notebook? Aditya, can you just put this game pin in there?
Yeah, sure.
Put the game pin and see if anyone has any doubts. I'll just upload this my Python notebook.
Adora, can you just show once again? 644.
Yeah, 1 second. 644 705.
Okay.
Yeah. Quickly join in, everyone. Till that time, I'll push the code on GitHub.
And
By the way,
yes, you will be learning GitHub tomorrow. Git and GitHub workshop is scheduled tomorrow.
so
So
you
you
in GitHub tomorrow, and if you want one like jhalak of GitHub, let's say I have this file, I copied it, I pasted it in week 3. Okay. Okay. MNIST ये भी काम करनी है, ये भी काम करनी है. अरे 1 second, इधर डेटा था. Shit.
so till the other time you just join the Kahoot quiz. I have posted the link in the chat.
So see, what I did was I just added my files in my local and I did get status. Okay. Okay. Get full. So get. Okay. Sorry. Git add. Get commit. Notebook added. Get push. See, something happened. I wrote actually 3 lines. Only 3 lines of code I wrote. So other things was useless. Just forget. 3 lines of code I wrote. And what happened was get hub. What happened was you have your notebook right here. See, so directly from my local, I uploaded something on internet without leaving my terminal. So that's something, a feature of GitHub. You would be knowing more about it tomorrow. Okay, and like everyone should know how Git and GitHub works because it's very necessary for every developer. So you can invite your friends and just join in quickly and we'll continue, please. So just this Kahoot and we'll end this session. Starting in 2. Okay, so how many participants do we have? Anyone having any difficulties while joining? So write it out in chat box or we'll proceed. Start now or anyone is joining? So or we'll start and just like get done with it. So 6:32 I'll start. Okay, sorry, Prachi. So sorry, Prachi. Did you join or not?
Otherwise, you have
Well,
just given a lot of time there.
I'm so sorry, but okay, she'll try
Okay,
again.
no problem.
Okay, so this is just revision. Just quickly answer. The first two questions would be very easy. I
Just
put
warm
a
up.
lot of time, I think.
Yes,
I should.
yes.
30 seconds is more than enough. Anyone remaining with the answers, or I'll skip? I think one or more. How many people joined? I think 46 now. So just answer quickly. Okay. So we don't have to wait that much time. Okay, Sridhar answered quick. Output of regression, what could it be? Come on, quickly. Thank you. Nakul, okay. So for small value of k, what could happen? There is something called as noise that we learned. I'm so sorry. So think like that. You have a lot of time. Okay, 6 people, just answer quickly. One more. Please, Husu. Yeah, okay, right. That's right. So for small values, it's probably that with noise, the our decision could affect. So that's why we want an optimal value of k. Performance of KNN by large values now. So what could happen? Think. Okay, five. Okay, two more people. Yeah. Mayur, Bhoyer, and Sonali. Okay. So distance. Aditya told you one distance. The name of it. It's
I
not.
can see the speed of marking the answers.
Don't do nearest. I told you the answer. Don't do nearest. It's not nearest. Okay, 10 people did nearest.
Okay, they confuse the K nearest neighbors. Okay.
KNN stands for K nearest neighbor, but actually the like
Yeah.
hexagonal section is called Euclidean distance.
How we measure the distance of each and every point. For that purpose, we use Euclidean distance under root of x square minus x1 square. That one.
In KNN. So see what could happen.
Time to answer the question. Read the question.
Yeah, you have a lot of time. Just think and answer. Actually, one statement is like the proper answer is one statement, and I reversed it to make it confusing. But let's see. We talk in low distance, right? We talk in low distance, like nearest neighbors, small distances. So I just inverted it. What could happen for longer distances? Yeah. So because actually small distance, then we have high confidence that the particular point belongs to a particular class. So I just inverted it. So for small distances, high probability. So for high distance, it could be a low confidence. Don't worry, it was supposed to be confusing. Noise. Come on.
We have shown you the meme.
Come on quickly, please. 3 people remaining. Just quickly fill answer. Thank you. So yeah, instance of speeches does not value it, does not match the label.
Think it like a spy. He's spying on someone. Okay, so there can be only one spy or a limited number of spies. Okay.
Kabir claimed highest. Congrats, Kabir. 8 places. How many true positive do you have according to the conclusion? So this is the reason I discussed this with you. You have a lot of time. Don't worry. Think properly. True positives. Okay. It's just wordplay in English. Okay. 6 more people. 7 more people. So quickly, if you. Okay. 3 more people. Right.
Sonali is not leaving the leaderboard.
Fixed position. Okay. Now true negatives. Now they know what the answer could be. True positive, if they know, then true negative would be easy, I think. Come on, 2 more. True, like correctly positive. Yeah, exactly. Now read it carefully. You have a lot of time. You developed a machine learning algorithm that classifies given email as spam or legit. And your client suggested that falsely claiming a legitimate email as being spam can be very damaging. Exactly, right? So falsely claiming spam. Think. Spam means positive. I added these questions because these are actually asked by your interviewers. You want to be very, very clear on this topic. Come on, 3 more people. A or B, what would it be? Falsely claiming something. Okay. Falsely claiming spam is a risk. So a spam could be also considered as here only it's written, no? Yeah. Okay, Samiksha made her way back on the leaderboards. Now for cancer.
Are you guys reading the question?
Yeah, how can anyone be so fast?
Yes.
Or only memorize that my concepts. Probably it's like that, yeah, healthcare, na, then I know what to be minimized because that's what actually everyone does. Healthcare, then okay, you have to reduce this probably. Here it's cancer. I told you about COVID. False event here is cancer. So cancer patients को free में भागने नहीं देना है ना. We don't want cancer patients to think they don't have cancer. Although we can predict that a particular person who is healthy, we can tell them that you have cancer, it's okay. But what you want to minimize, right? You want to minimize the number of people who you tell that they don't have cancer, but in actually they have cancer. It's like that. Let's see who won. Okay, Harshila, congrats. Third. And second, congrats.
Sonali.
So thank you so much. This was the end of today's session.